Okay, this is section 3.6, and what we're focusing on here is inequalities and how we graph systems of nonlinear inequalities. So this is actually a warm-up right here, and what you're doing here is thinking back to linear inequalities. Now, if you think about inequalities, inequalities are equations that have these symbols. Actually, they're not even equations. I take that back. Inequalities are expressions that have these symbols in them. So either are less than or greater than, or less than or equal to, or greater than or equal to. Okay, any expression that has one of these four symbols in it is an inequality. So what we're doing here is we're looking at how we actually graph an inequality. So the first step in graphing an inequality is turning our inequality into a y equals mx plus b. Okay, mx plus b. So what we're going to be doing is we need to turn this so we've got y on one side and mx plus b on the other side. And what we have to do, instead of equals, we're going to have one of these four inequality signs in here. So your inequality sign just stays where it is, and what you're going to want to do is move your y into a position where your y is isolated and you've got mx plus b on the other side. So in this first one right here, you'll see we can just add y to the other side. So we got y here and y, we've got our greater than, and we have here x, and then we subtract 5, so we get x minus 5. Okay, so our equation right here is y is greater than x minus 5, or we can read it from left to right. X minus 5 is less than y. Either way, it doesn't matter how you read it. Okay, now what we're going to want to do is we're just going to graph this like it was just y equals x minus 5. So if we look at it, our slope, remember, is m. So this one would have m equals to 1, and b, our y-intercept here, b would be equal to negative 5. So in this case, we're just graphing a line that has a slope of 1 and a y-intercept of negative 5. Now, before we can graph this, we have to figure out if we graph this with a solid line or a dashed line. Now, the reason that we're doing this is instead of graphing a single line, we're actually graphing a region. We're looking for the region that satisfies this inequality. So we're looking for all the values of x and y that give us x minus 5 less than y. Or we're looking at all the values of y that give us the greater than x minus 5. So all the regions where our variables plugged into this equation or inequality satisfy that. So the difference between a dashed line and a dotted line, or dotted line and a solid line, is that a dashed line means that our line is not part of that region, and a solid line means that that line is part of our solution set. So when we have this line underneath our little alligators right here, this means that or equal to means that whatever symbol we're talking about, so if we said 5 is less than or equal to x plus 5, that means we're looking for all the values, including whatever this inequality refers to. So when we have an or equal to here, that means that we draw a solid line, and that means that that line is part of our solution set. When we do not have a or equal to, means that we draw a dashed line right here. So let's go ahead and look at this. The second part is we look at this equation right here. So y is greater than x minus 5. Greater than means we're going to look at all the regions above our line. So when you're looking at the shaded region, whether it's going to be above or below the line, you're looking at that from y's perspective. If this was y is less than x minus 5, we would shade all the regions below. Okay, so remember, your inequality symbol tells you if you draw a solid line or dashed, and then you look at y to see how that relates to your equation, and that determines if you shade above. If it's y greater than, you shade above. If it's y less than, you shade below. So let's go ahead and look at our solution here. So in this one, we get y greater than x minus 5, so that we shade above. We plot our line. It has a y-intercept of -5 and a slope of 1, and we shade the region above that. Now what I'm going to do is I'm just going to go through and put up the other solutions here so you can graph a couple of these and see if you get them correct. You can see right here, by bringing 2x over, we would get y greater than -2x plus 10. This means it would have a y-intercept of +10 and a slope of -2. So right here you can see, and because it's y greater than, we shade the entire area above. This is y greater than or equal to -3. So this means that our y-intercept is -3, and because there's no x term, we're just going to have a horizontal line at y equals -3. Now, because this is a or equal to, it means we're going to have a solid line where y equals -3 is part of our solution set. In our previous two examples, we had dotted or dashed lines because our lines were not part of our solution sets. In this last one, we go ahead and solve this, and we get y is greater than 2x minus 5 over 3. Again, a dashed line because it's just greater than, not greater than or equal to. So this is just the warm-up. If you are having any trouble with how to graph these linear equations, keep these up here and review them. Go to Khan Academy, check some other ones out. But since we're going to be working with non-linear systems, graphing linear systems is just a good way to get warmed up on these.